Hello everyone, my name is Shweta Gupte and today we will be talking about paranoid cryptography and one-time signatures. Um, One-time signatures are used or they rely mainly on hashing functions and they are ideal for some quantum security purposes. However, paranoid crypto is a mindset and a toolkit that reduces some realistic cryptographic risks. Hence, we'll discuss some of the trade-offs and the unique ways of identifying and eliminating certain threats. To begin with, let's break down or recall ourselves with what is hashing. Hashing is basically a one function which turns some data and string into some non descriptive text or reverses it. The hashing is basically a sensitive information, including passwords or messages, which can be converted into some by some hashing algorithms and can is unreadable to the humans, but needs is difficult and extremely difficult to decrypt. Hashing basically has one-way direction of encoding, which is slightly different from encryptions. In encryptions, you have two-way encoding and you have the public key and the private key. Whereas in hashing security, it is only one direction encoding that happens, and both of these require some sort of a SSO technology to enable a remote workforce and reduce certain frictions amongst the users. Now, in paranoid crypto and one-time signatures, when we talk about mindset tools and applications, we are looking at the crypto mindset toolkit, which assumes that certain failures are going to happen for the hardware, certain equipment, certain algorithms, certain conditions, they are going to fail. When we verify keys and the randomness, we rotate certain secret keys and use of hardware trust. Yes, when it comes to the one-time signatures, certain examples are Lamport and Winternitz, hash-based post-quantum, one key, one message, large signatures, state management, and so on. So used in paranoid designs basically for one-time signatures. When it comes to applications, certain key applications are XMSS and SPHINCS, secure boot firmware, cold storage wallets, high value asset protections, and so on. So let's play a little video to see how hashing itself works. Let's say we have a private key and a message has been hashed and created a signature. One-time signature key stage that has produced this particular uh, jar, jumbled up message going ahead. Yes, we have just moved the private key and hashed it so that the signature is produced. Alright, so now let's come to what is paranoid cryptography. We are looking at some sort of a flow where you have a vulnerability detected. You have certain different connectors where hashing is happening and vulnerabilities at different stages of your flow. The mindset approach basically says that we assume the components can fail. There is randomness generators that can fail, parameter choices that can fail, the libraries that you're using can fail, versus minimizing some long-term secrets. Everything is possible. Use of hardware roots, basically you trust certain pieces of hardware and so on. Practical tools basically are projects like Google's Paranoid Crypto provide automated checks for weak keys, insufficient entropy, and use of nuances, catching dangerous crypto artifacts before it is deployed. Yes, let me move the. All right. some critical for these things are critical for your high value assets, nation threat related concerns, and let's see. Let me stop this. Move the camera about. All right. I don't think I can move the camera about, but he's being the national threat and some sort of security to enhance some quantum computers. All right. Um, if I have to explain the one-time signatures, the one thing is it is basically a digital signature. Core concept is sign exactly one message per pair, reusing the same key. Pair catastrophically breaks the security down. Basically, your message per key pair is going to be reused in the same pair catastrophically and breaking down the security. Hash-based foundations basically are you have the Lamport or one-time signature relies purely on the hashing functions. No number theory assumptions needed for security. One way to do an interactive activity is you create a small simple hashing function. Each step depends on the previous hashing outputs. Now, where OTS is applied, which is one-time signatures or one-time signatures are mainly applied in post-quantum signatures where XMSS and SPHINCS built many use schemes from OTS via um, Merkle trees or providing some quantum resistant securities. Um, Secure boot systems like firmware and bootloader signing, where each update is unique and requires some sort of a single use verification. Now, there is also cold storage where we use the high security wallets and blockchain primitives that deliberately limit key reuse for maximum protection. You can simulate basically some multiple messages with the same OTS to see if the security has degradation or not. What are the benefits of paranoid crypto plus OTS? Minimal assumptions. Hash-based OTS depends only on one-way hash functions, not factoring or discrete logarithms. Excellent post-quantum safety. Enhanced audibility. Few moving parts make system easier for us to use and verify, and formally analyze for correctness. They also are early detection of paranoid checks flags, um, make it more reachable. Critical trade-offs between that needs to be considered between the OTS limitations versus the paranoid crypto cost. OTS is one-time constraint. New key pair required per message. Operational overhead. More checks are required and rotations are required for HSM logging. Large signatures, kilobytes versus hundreds of bytes for ECDSA. State management accidental key reuse destroys certain kinds of securities. One hands-on exercise that you can try yourself is calculate storage requirement for 1000 Lamport signatures versus ECDSA signatures. Yes. Developer frictions in paranoid crypto costs, stricter rules, slow iteration cycles, plus risk complexity risk. The tools can create false security sense. Some practical applications, implementation guidelines when you are using paranoid crypto are automated paranoid checks, integrate tools like Google's paranoid crypto into CI/CD pipelines to scan cryptographic artifacts before release. Choose OTS when post quantum assurance is needed. large signatures acceptable, and state management feasible via Merkle trees. Again, paranoid hygiene and hardware security modules are the everyday applications for conventional signatures. Set up, here's something that you can try. Set up automated key strength validation in your new projects, and go from there to see how the performance of paranoid crypto is. Right. So essential resources for further reading are Google's Paranoid Crypto, comprehensive toolkit for automated cryptographic hygiene. You have a GitHub repository link as well if you want to do some reading on it. NIST hash-based signatures, official guidance on XMSs, post-quantum signature standardization efforts that are done by the NIST as well, and Lampert OTS deep dive, technical specifications provided, and the crypto services offered by Google itself. For the next steps, again, I'll come back. We'll go look at the interfaces side by side, analysis of Lamport versus Winternit's algorithm versus XMSS and Phoenix's in signatures. There are some hands-on pseudocode walkthroughs that we'll go through, hopefully, and security audits for analyzing your code base, key pairs. That's it for now.